Hey everyone, Mihai here, and in today's video I'd like to show you how we can make a high poly Nanite ready floor tile that we can customize with vertex paintings and decals, create unique pieces with Unreal's fracture system, and quickly implement runtime virtual texturing to seamlessly blend other meshes with our floor tiles. So let's jump right in. Here we are in Blender, and the first thing I want to make sure is we are working in the correct unit system. In the Scene tab, make sure that you change the length to centimeters. I also changed my grid size to a smaller number so we can use the grid snap option when we move things around. Unreal uses centimeters for its scale, and Blender is set up by default to use meters. I also have my emulate 3-button mouse option enabled, and the key is set to Alt on Windows or Option on Mac. I'm currently using Blender 3.2, but you can use whatever version is available when you're watching this video. This will not be a step-by-step tutorial, and I will be narrating over my time-lapse. So I start off with a 4x4 meter plane, which roughly translates to a 2K or 4K texture. Anything larger than that and it would look blurry if you want to unwrap a 10 meter plane, for example. I'm also using a paid asset called Pivot Transform, but it's optional. You can also use the 3D cursor to move your pivot. I just find it easier and quicker. I'll leave a link to the asset in the description. I start off by making a 50 by 50 centimeter cube, just to get an idea of the brick size that I'm going to use. I'm using the Unreal Mannequin to get a real-life example of how this would look like in a game and reposition my elements accordingly or resize them. Now I realize that the brick is too small and I'm trying to get a better composition by resizing it. And having the pivot point in the corner helps with that. You don't have to make them exactly the same way I did or the same size. Just play around with sizes and go with your gut. Make them what feels right for you. Having the pivot point in the corner helps with positioning and duplicating our pieces in each of the 4 corners. I just added 400 centimeters to our X or Y position, and that automatically moves the pieces to where the seam will be. Now I'm trying to duplicate the left and the top side to create a border around our tile. That way I can get a better idea how many pieces I need to fill out the center. You don't want to go too granular and create too many tiles. That will make your composition look too busy, and having all those details from the textures and our sculpting details would create too much visual noise. With this piece, I'm trying to create an inset corner by using the Boolean tools. If you're not familiar with them, they're built in inside Blender. You just have to enable them from the add-ons panel. For this part of the process, it's very important that you move the mannequin around and get an idea of how big your bricks are, if they're too large or if they're too small, if they look realistic or not. Once you're done with creating everything, you can remove the side elements that are just duplicates and keep the ones that are unique. Using the ZBrush or stylized brush pack for Blender 3. It's free. And don't forget to apply the scale to your meshes, because if you don't do that, you're going to get some issues when you're trying to sculpt on them and your brush is going to act all crazy. I'm now remeshing the bricks to around 0.4 centimeters. I find that value to give the best results in terms of sculpting resolution. For sculpting, I'm using a free pack called ZBrush Orb Stylized Brushes. I'll put a link in the description where you can download it. I'm using my mouse real quickly just to create some edge wear. You don't have to be super specific, just click and drag, it's fine. This is just going to be a base for our mesh, and our textures are going to do the heavy lifting for us. Make sure you go around on all the edges, and don't forget to use the mannequin to get an idea if you carved out too much out of an edge or too little. This way you will get a better idea of your size and how the brick would look like in an actual game. We can sculpt the unique pieces out of every brick, or if you want, you can just sculpt 3 or 4 of them and then you can duplicate and stretch them out or resize and just come back with your sculpting brush and add more uniqueness to those duplicate bricks. In a second pass, we're going to add more details by carving some holes or adding some dimples on them, and that way we're going to get some more uniqueness out of our bricks. Now I'm using the clay strips brush to quickly carve out big chunks of each rock just to make a couple of dimples and create some edge damage. Again, you don't have to be specific, just create some small marks and then you can go over with your smooth brush if the edges are too rough. There's no right or wrong way to do this. This process will just add some unique details to our cavity map and the textures that we're gonna add on top of it. Now I just switched to a stencil brush called Orb Rock Detail to add some textures on top of our bricks. This will create some nice details for our normal map, and it will help with creating some variation on our non-even surfaces. Just click and drag on top of the surface with your mouse. You can just put the mannequin on top of your bricks and see if the stencils are too big or too small. And that way you can create a better texture. Switching to another brush called Orb Rock Details, which has a more porous texture to it. This will help give us some small cavities in some of the smoother parts of our bricks. With this brush, you don't want to go too large of a size or make the strength too high, because it will just create some very large marks and it would look unrealistic. Now that we're done with our sculpting phase, we can duplicate our bricks into the correct place by just adding 400 centimeters to the Y or X position. And again, duplicating the top and the left sides of our mesh. The last step is to shift our bricks on the Z-axis a bit up and down. This way we're going to create some unevenness between them. We can also rotate them a bit, and that way we're going to create some nice crevices where pockets of dust or sand can gather. Do keep in mind when you're rotating or shifting the bricks that you don't rotate them to very harsh angles or create large discrepancies between one brick being way up and the other one being way down, because you're going to create some bad differences that are going to show up in our height map. Also, if you're going to move one of the corner pieces or one of the sides pieces, do keep in mind that you have to move all 4 of them. Or if you want to move the sides, remember that you need to select both of them. Now that we're done with the sculpting phase, I'm just going to join all our bricks together with a plane, and we're going to export it as a high poly FBX. We're just going to limit it to the selected objects and select the mesh. For everything else, we can keep it as the default options. Depending on your computer and the number of triangles our mesh has, this can take up anywhere from 30 seconds up to 2 minutes. As long as your computer is still working, don't worry, your file's gonna save just fine. Now that we saved our high poly mesh, we're just going to select the simple plane and export it as our low version of the mesh. For baking, we're going to use 3D Coat. If you're not familiar with it, it's very similar to Blender. Just as Blender has spaces like the shading space or the modeling space, 3D Coat has rooms. We're just going to use the retopology room and the paint room to bake our high poly maps. You can change the rooms from the top left corner. Once we're inside the retopology room, we're just going to use the import mesh for vertex painting or reference. Importing our high poly mesh can take up anywhere from 30 seconds to 2 minutes, depending on the triangle count and your computer. Once that's done, check to see if there are any issues with your normals or any missing pieces. Next, we're gonna load our low poly mesh as a retopo mesh from the drop-down menu. Once loaded, you can confirm the import by pressing the Enter key. You can see your low poly mesh by moving things around. It's represented as a green checker plane. Before we can project our details, we're gonna have to do the occlusion map and cavity map in the paint room. For some reason, this doesn't work after we project our high details. In the paint room, you can find Calculate Occlusion either in the Textures dropdown or the Edit dropdown, depending on which version of 3D Coat you have. In older versions, it used to be in the Textures menu, but they moved it to the Edit menu in newer versions. For the ambient occlusion map, we're going to use the default settings. The only thing that we're going to change is enable separate paint objects. You can also turn down the light count to 2048, as that would decrease the time it takes to calculate it. Same as with the import, this can take up anywhere from 30 seconds up to 2 or 3 minutes. Be patient, and once it's ready, it's going to show up in the right hand side in the layers panel. For the local curvature map, we're going to change it from local curvature RGB to just local curvature. And we're going to change the intensity from 100 to about 25. I found that number works best with our mesh. You can also change the size to 2048 and select separate paint objects. If we're to use the local curvature RGB, it creates some issues, some tears. I don't know if it's a Mac issue or if it's an application issue, but changing it to just local curvature seems to fix it. Once the curvature map is done, you're going to see it in the bottom right corner in the layers panel. It's going to be disabled by default, so we have to switch it back up. Once that's done, we're going to go back to the retopology room and select Bake from the top menu. The option that we're looking for is Bake with normal map plus flat displacement, not the one highlighted in yellow with just the normal map. 3D Coat's baking room is quite easy to understand. All you have to do is put your outer shell or your outer cage to encompass your high poly mesh. Change your snapping method from normal to snap to outer surface. And for the inner shell, we don't have to create a very large cage for it. You can just keep it to 1 or 2. For the outer shell, depending on your mesh, you can go to 30, 40 as the value. For the baking process, you can select the normal map software preset to be either Unreal or Unity. For our map size, I'm gonna go 4K, and that's about it. We can leave everything else to the default settings and it will bake just fine. Once the baking process is done, in order to see the low poly mesh and our textures, we first have to disable or hide our high poly mesh from the bottom right corner in the sculpt tree. We're just gonna click the I button to disable it. Otherwise, you're not gonna see your low poly mesh since it's underneath your high poly one. We can switch back to the paint room, and here we can take a look at our results, check to see if there's any issues with our map. In the texture editor, you can see, if you don't see it, you can enable it from the Windows menu at the top. First thing that we're gonna do is fill our base layer, like layer 1, with white. There's an issue with 3D code and ambient occlusion. When you're exporting it out, the ambient occlusion map just looks pixelated, so we're just going to use our color map as our ambient occlusion map. Another thing that you have to do is hide the normal map and enable the displacement map in the layers panel. If you don't do that, the height map will be empty and you're only going to get the normal map. If you enable both of them, it's going to create like a double normal map. Again, I don't know why. It's a quirk of 3D code. You can select the output mesh to be an OBJ. Just rename it to whatever you want. I'll just put the name of the mesh. 3D code also gives you some presets to choose from. I'll go with Unreal 5, which gives you most of the maps that we need. All we have to do is create a new texture, select cavity from the drop down and rename it to cavity. We can keep it as RGBA 8-bit or RGB, doesn't matter. Just click export. And that's it. Here we are in Mixer. And we're going to start by creating a new file. The working resolution doesn't need to be changed to 4K, as that will slow us down. First, we're going to change our size to a 4x4 meter plane and our texture resolution to 4K. And we're going to import our baked maps from 3D code. We're going to import our ambient occlusion first. As I mentioned, there's an issue when we want to import the original AO map, so we're going to use the base color map instead. Next, we're going to select our cavity map, our normal map, double check to see if there's any issues with it, and last, our displacement or height map. You can play with the strength of our displacement map by dragging the slider to the right. I think 20 is a good value for our tutorial. We're gonna get these jagged edges because there's a harsh difference between black and white on our height map. And the way to fix that is opening it up in Photoshop, GIMP, or whatever photo editing program that you have access to, and just applying a small amount of Gaussian blur, and that will create a nicer looking fade between those harsh lines. In Photoshop, I used 7 pixels as the amount, and that seems to work perfectly. Save the file as a modified version of our original displacement map. Back in Mixer, we're gonna replace our original displacement map with the blurred one, and you will see that those jagged edges are pretty much fixed. We still have some small issues with some lighting conditions and some normal stretching, but it's nothing as bad as it was before. You can check how our textures tile by using the tiling preview in top menu or by pressing the T key on your keyboard. If you're not familiar with how Mixer works, it's pretty much the same way as Photoshop does, by just using stacking layers one on top of each other and using layer masks. We start off by creating a solid color layer just so we can get a better understanding of how our displacement map looks like and how it tiles. Next, we're going to add our first surface layer. What I'm looking for is a nice rock base. If you don't see any materials in your local library, you first have to download them from the online store. I'm looking for a material called Icelandic Smooth Rock. It has some really nice cracked details that are gonna complement our sculpting details as well. As for the base color, I'm looking for something that's brownish red. Something that would look good both at night and in sunlight. I have a couple of saved hex values that I'm going to use for the color options, as I've tried them out inside Unreal and I think they look the best. Once we have our base color, I'm just gonna disable the height blending because I want my material to wrap to our underlying displacement map. I also want to increase the strength of our material displacement map as well. One issue that Mixer has is the way that lighting works compared to Unreal. Is you're going to have to switch through a lot of these lighting presets, indoor, outdoor, to really get an understanding of how your materials would look like inside Unreal. Because a lot of times they look amazing in Mixer, but when you import them into the game engine, they completely break down. Next, I want to add a solid color layer that will work as an edge highlight. Mixer has some powerful masking tools, and I'm going to use some of them for this layer. I'm going to add a curvature mask, and I'm going to select the edges only for its option. And I'm going to select the base curvature map, the one that we baked inside 3D Code. You can change your view by pressing 9 on the keyboard, or from the top left corner, you can select from PBR material to just layer mask, and that way you're going to see only the active layer mask. With this, you can make a really tight selection and you can really tune how much your mask should affect the selection. I'm trying to get some nice edge highlights by playing around with the sliders. In essence, this is what Mixer is all about, just dragging those sliders until you get something that looks right to you. Don't forget to check how they look on and off, how they look in different lighting settings. Once you're satisfied, create another solid layer. This one will be for the cavities where we want to, enhance them with a darker red color. Dark brown would work well as a dark gray if you want something that's neutral. In order to see the colors better, you can just invert the height blending, and that way you will only see the active layer. Just like we did with the edge highlights, add a mask stack to it, create a curvature map, and from the options just select cavities only for our base curvature map. Press 9 on your keyboard to select the current active map and make your selection however you think it would look good. You can switch between the preview of our PBR material and our layer mask by quickly pressing 9 and 1. And this way you can see how our selection affects the different parts of our mesh. You can see how this really enhances the quality of our shadows, and combined with the highlights, it just gives a better silhouette to individual rocks. Next, I want to add some gravel or some small pieces of rock that would fill those cavities between our individual stones. I'm looking for material called gravel dirt road, as I did some testing and I really liked how this one looked combined with our Icelandic smooth rock for the base. Once added, play with the height blending or the underlying wrapping and try to get a good balance between the two materials. What you don't want to do is turn up the wrapping too much, because that way it would sink too much into the stones, and you want to fill up those cavities between our rocks, not make them blend with it. For the color, I'm looking for a light brown that would go well with our base material. You don't want to have anything that's too bright, otherwise it would just draw too much attention and it would pop up too much and make the whole thing look unnatural. A great way to quickly match your colors is by clicking on the albedo color and just use the match to underlying slider. That way the top color takes some of the nuances from the bottom one. It's very important that you try out different lighting modes and look at your tiles from different angles and moving your light by pressing Shift and right click and just dragging on your screen. Another way you can check to see if the contrast is too much is by switching from PBR to just albedo. And that way you're going to see only your color base without any lighting influencing it. And that way you can see if some of the colors are too bright or not. I realized that the gravel is a bit too grainy for what we're trying to achieve, and I turned down the tiling to just 1. And I double check by enabling our own tiling to see how it would look on a larger plane. This concludes our base material, and now we want to create a bit of variations for it. We're going to create a blend material inside Unreal, where we can paint parts of our mesh with different materials. What I want to do is create a version where our stones are a bit damaged and cracked. And for this, I'm using the concrete damaged material. I'm just trying to match the material color to our base color. A great way to do that is by switching with 1 on your keyboard to the albedo color and just trying to match them as best as possible. Once you're done with the colors, you can switch back to the PBR and just decrease the height. We don't need any sort of displacement from our base mesh, because inside Unreal we're going to use the displacement of the actual geometry. Here I'm increasing the contrast so those cracks would really pop when we're painting them on top of our base material. Next, we're going to disable what we just created and make another variation one that would work well with some moss or some sort of vegetation underneath. This one will be a combination of two materials layered one on top of each other. I'm looking for a material called mossy floor, and this will create the base. I really like this one because it has a bit of concrete pieces scattered throughout the moss. Try to blend the materials together. The concrete patches with our base, we're trying to make those two brown colors go together as seamlessly as possible. Next, I'm gonna increase the contrast to get a bit more details out of this. Same as our other variations, we don't need any height blending for this one. For the second part of our moss variation, we're going to use the mossy wall material. And this one has some nice rock details as well. Here I'm looking again for something that's a bit more warm and in color. What I realize is the colors are a bit too powerful, and I just invert the source on this particular layer and it just inverts black to white, and now as you can see it blends much better with our mossy floor. So this will be our third material, and the last one that we're going to do is a backup variation in case you want to use it or make it as a decal. We're going to create a lichen version where the stone has been out into the rain or weather for a long period of time and lichen starts to grow onto it. I really like the lichen rock wall variation because it also has some nice rock details scattered through it. I lowered down the tiling of it because I thought size was a bit too small. And just like with the rest, I'm going to try and match the base albedo color to our underlying mesh colors. If you want, you can get a better glance by moving the height blending up, and this way you're gonna get some parts of our base Icelandic rock pushing through. Once you're happy with your color, you can lower back the height and disable the material as well. Next, we're going to export all of these materials into their own subfolders. Make sure that the create subfolder option is enabled and the size that you're going to export is 4K. Once you're done exporting the base material, you can go back and enable the damaged version. In the export settings, change the subfolder name to include the name of your variation layer. Repeat the same process for the rest of our materials, the mossy and the lichen version, by just changing the name of your subfolder to include the name of each variation layer. Once everything is exported, we're going to go back into Blender and create our Nanite mesh by using some of the maps that Mixer created. Here we are in Blender, and I start off by making another 4x4 plane. And the first thing that I want to do is, in order to be able to see how our displacement map is going to look like, I want to create a new material and import the maps that we created inside Mixer. We just need the albedo and the normal map for this. For the normal map, you can set it to non-color once imported instead of sRGB. And in this way, we're gonna get a preview of our bricks. I also want to change my UV editing preview to be the normal map. In order to apply the displacement map, we're gonna need a lot more resolution. So we're gonna add a subdivision modifier and increase the number to 8 or 9. If you don't see your triangle count, you can enable it from the overlays panel in the top right corner. After you apply the subdivision modifier, add a new displacement one and change its coordinates to UV. Decrease its strength to about 0.1 or 0.2. You can also set the midpoint to about 1.1. I found that value to work best for all types of meshes. Next, create a new texture and select our displacement map that we exported from Mixer. It should be the base material displacement map. Our mesh looks a bit fuzzy right now, so we're gonna add another modifier called Smooth Corrective. For its value, something around 0.2 would work best. And you also want to check the only smooth and pin boundary options because we don't want to change the shape of our initial plane. Apply both modifiers and don't forget to change your mesh to smooth shading. Once this is done, what we want to do is create some depth to our plane. And in order to do that, we're going to first select the edges around our plane and we're just going to extrude them down. Once they are extruded, you can level them by scaling them on the Z-axis and just pressing 0. That will flatten everything down. This will help once we import this back into Unreal when we want to fracture this and make some pieces out of our tiles. Having a side and a bottom would create the illusion of having an actual brick tile. Next, in the UV editor, we're going to mark our seams for every side piece that we just created and for the top. When we extruded down our edges, we created some small issues with stretching our normals, but we're going to fix it in a bit. Check to see that you have every corner marked as a seam. And then just select your bottom edges again, right click and fill out that gap. In the bottom left corner in the options panel, make sure you have disabled beautify because this doesn't have any effect on our bottom panel. Now that we have all our sides, it's time to unwrap our mesh. Select one of the faces from the side and press L to select every linked face to it. And we just want to scale it up a bit so it fits inside the UV map. Having our side pieces rotated 90 degrees and on the side of our normal map looks a lot better because of those horizontal lines that will look vertical. Same thing with the other sides. Select one of the faces, press L, and then do a cube projection. Rotate them 90 degrees and just put them on the left or the right side. Once you're done with the edges, again select one face from the bottom, press L to select everything, do a cube projection, and for the bottom we don't need it to stretch out on the whole map. We just want to put it in an empty area so there are no seams or no gaps between the bricks. We have now finished our seamless nanite tile, complete with UV on wrapping. In order to fix the stretching on the side, just create an edge loop and place it at the top and another one the bottom. But instead of putting it all the way down, just put it right above the bottom edge loop and it would fix the stretching. All that's left to do is export this out. And for this, if you're not familiar, there's a great add-on. It's called Better FBX Exporter that I'm going to use. What I love about it is that it already has some presets. For example, you can automatically select the Maya Z up for your axis. Another thing I found is in some cases, it actually works better with older versions of FBX files than the standard one from Blender does. Here we are in Unreal 5, and we're going to start off with a brand new third-person template project. And the first thing that I want to check is to see that we have the web browser plugin enabled. This will help us use the Quixel Bridge plugin, as without it, it doesn't work. Another thing to check is that you are logged in. You can access Quixel Bridge from the drop-down menu in the top left corner. Next, we're going to create a new level. And for that, we're going to make a new folder so we can keep everything organized. You can select the basic template for the level. Make sure that you save it after you created it. You can rename it however you want. I'm going to use Tiles Showcase as the name. Once that's done, we're going to create a couple of more folders. One for our meshes and another one for our textures. In the meshes folder, we're going to import our Nanite FBX. And when you're importing, make sure that you have the build Nanite option enabled and disable the import textures and do not create material. Because we're going to create our own material and the textures, we're going to import them separately. You're going to get some warnings, but we can ignore them for now. We can check to see how our mesh looks like inside Unreal. Now it's time to import our materials. You can create a separate folder for each, or you can import them all into the same folder. I chose to create a separate folder for each layer. For the materials, we only need a couple of maps. We don't need the displacement map, for example, or the metalness if you don't use it. So when you import, just select the ones that you know that you used. Once imported, make sure that your roughness, your ambient occlusion maps have sRGB disabled because we don't need the color information from them. And if we keep those options enabled, our roughness might be rendered incorrectly. The only map that needs sRGB is the albedo map. Do the same thing for the rest of the materials. For the last material, the lichen one, you can create a new decals folder or import them here in the layers folder. I chose to create a decals folder in case I want to create more variations of it. Double check to make sure that you have sRGB disabled on all your non-color maps. Once you have imported everything, make sure that you save your project. Inside Quixel Bridge, because we're going to use a feature of Quixel Bridge where you can select 2 or 3 material instances and quickly create a blend material from them. But in order to do that, we first have to download them locally, because if we select them online and we try to create the blend material, it's going to give us this generic error that we need to select material instances first. The way to get to these settings is the icon near the quality dropdown. When you download anything locally, it's going to create a folder called Megascans and a bunch of other subfolders. The materials are going to be inside the subfolder called Surfaces. You can use the filter button to quickly filter out just the material instances. Select all 3 and go back to Mixer and press the Create Material Blend. I'm going to rename it Material Instance _ Seamless Tiles Blend. You can create a new folder called Blend Materials, or you can save it in your Materials folder. It's up to you. Remember to clear out the filter so you can see everything else. And taking a look at the material that it created, we can see that we can just replace the maps that Bridge used with our own maps. Since this is a material instance, it has a parent material or a master material. I want to duplicate it because every time you reset or restart your project, some of these master materials are going to be overwritten with the online version that it has, and it's going to erase any changes that you make to the master material. So we're just going to duplicate that one, give it another name, and put it in our materials folder. That way we have a local copy of it. that we can edit to include stuff like runtime virtual texturing or make it work with the dynamic sky plugin. Open up your blend material instance and change its master material to the duplicate one that you just made. Now we can start replacing the layer maps with our own mixer maps. For our base layer, I'm going to use the stone tiles maps. Unreal usually uses packed maps that pack multiple textures into their RGB channel, but for our use case, we're just going to use the roughness map that we got from Mixer instead of the packed map. We could export a packed mask from Mixer that would contain the roughness, metallic, and ambient occlusion maps into individual channels. Since we're not using anything metallic and they have a separate ambient occlusion map, I don't think we need one for this use case. Next, you want to enable the use base layer adjustments, and don't forget to enable the checkmark on the right as well. That way you're going to get the options to change saturation and color and stuff like that. Once you're done, don't forget to save the material. Now we can do vertex painting on our mesh. Switch to the mesh paint mode, and from the bottom right panel, disable the other layers and just keep one active, and you can try out the paint mode on your mesh. You can further tweak the material by going inside the material instance and enabling the individual controls for each layer. For example, the blend amount, contrast fall off, or saturation. Play around with the sliders. As I mentioned, if you don't see the individual controls, don't forget to enable them from the checkmark on the right side. In case you have some issues with one of your layers, enable the roughness minimum and change it to 1. I think having the minimum roughness set to 1 blends our colors better. You can use this technique to create any number of materials. Don't forget to duplicate the master material so it doesn't get overridden by Quixel's own online versions. I'm now going to duplicate our mesh and create a larger grid. I'm going to go for a 3x3. You can see that if you select all the meshes, you can actually vertex paint between them and they are treated as one element. So this way you can seamlessly blend your tiles and you can also seamlessly vertex paint between them. And I want to start off with some mossy sides, just so I can see how it would look like. You don't have to be specific with your placement, just create a moss border around. And then I'm switching to the damaged concrete and just put a couple of brushes here and there to create some variation. And now you can quickly see from just one material and one mesh, we can create a whole floor tile set that looks unique. And all we had to do was create a blended material and paint some parts. You can try out and see how this would look like by just placing your player start actor and pressing the play button. Because we have actual geometry, this also looks quite good when you're looking from a very low angle. You can actually see the geometry of each tile brick. Don't forget to save your level. Next, we're gonna start off with our fracturing system. And the first thing that we need to do is duplicate our original mesh and disable Nanite from it. This is very important because currently our mesh has a bit too many triangles for the fracturing to work. We need to reduce the triangle count down to about 10% or roughly 50,000 triangles. Select the middle mesh and change the static mesh from the Nanite one to this new duplicate one that doesn't have Nanite enabled on it. And in order to do that, all you have to do is go to Nanite, click and set disable. You can check by hovering over it and you're going to see at the bottom it says Nanite triangles 0. Next, switch to the modeling tab. And the first thing that we want to do is a simplify. This is similar to a decimate. For the sample type, we want to use UE standard. And you can zoom in and you're going to see these blue lines going across the mesh. Once the calculation is finished, those blue lines are going to disappear. And you're going to get a lower triangle count. Currently, we have around 250,000 triangles. And I'm going to put in around 20%, which is roughly 50,000 triangles. Click the accept button in the middle and then do a remesh. What this would do is spread out all those triangles evenly across all our faces, because currently the density is very high on the top mesh, but not so much on the sides and on the button. Wait for the blue lines to disappear and the accept button to become active. Click accept. Switch to the fracture mode. And the first thing that we need to do is create a geometry collection. Click the new button. And we can save it in our meshes folder. You can rename it to be a unique name or just leave the default name. Once the geometry collection is active, then we're going to select the radial fracture type. I think this works best with what we want to achieve. Think of this as a panel that was fractured because some roots started growing out from underneath, or there's a tree coming out of it. And I found that radial fracturing works best, especially if we don't have a lot of pieces. This was the reason why we had to create the sides and the bottom of our mesh in Blender before we could import it here. Because when these pieces will be fractured, Unreal will automatically apply a material to the sides of these fractured pieces and it will automatically generate new meshes. Play around with the sliders and the values until you get something that's not too busy, but it has enough pieces to make it look interesting. I realized that splitting this into 8 sections is a bit too much, and I go back and lower it down to 7 and the radial steps to 3. I think this will give us better pieces. You can test out the fracturing and see how it looks by first clicking the fracture button and then dragging the explode slider at the top. Once you're happy with it, all you have to do is from the left side panel, go to Utilities and press the To Mesh option. This will save your pieces to a static mesh. You can leave the settings to be the default. Once this is converted, you're gonna need to save all the individual pieces as static meshes. And you can either hide or delete the geometry collection from the outliner. As you can see, all the individual pieces are still there. And you can also drag them from the content browser and add them on top of the ones that are already in the project. As I mentioned, Unreal automatically creates a second material slot and assigns a new material to the sides. By default, it seems that it used our own blend material, which is great. Next, I wanna smooth out some of the edges and fix some of the issues that it created. And in order to do that, we're going to go back to our modeling mode. And the first thing that we want to change is the pivot point, because currently it's set to the tile mesh position. We want to increase our triangle count to something around 20 to 50,000, and we're going to remesh everything. And you might actually get some issues with some holes with some of your meshes. And for that, we need to use the hole fill or the H fill, which will automatically detect any holes in our mesh and automatically fix the issue by welding the vertices. Next, we want to apply a smooth from the deform, and this will create a smoother edge to our fractured piece. You can also do some sculpting. For example, our front is very pointy and I want to make it a bit more smooth. And in order to do that, you can actually do a bit of sculpting, similar to the way Blender works. Just select the inflate brush to inflate the mesh, and then just press Shift to do the smoothing on top of your inflated mesh. If that doesn't work, you can try to do a flatten on that portion and then try to smooth everything back to a better value. I find this process a bit tedious and I don't usually bother to do it very much. Once you're satisfied with your sculpting, don't forget to remesh again so you get a better geometry. And that's how you can create an individual piece from your mesh right inside Unreal. I'm gonna do a couple of more of these just to show you how the process would work with different types of pieces. First thing, change the pivot to be in the center, do a remesh, and now you can see there are some red spots. Those are holes in our mesh. Just select them all and click accept. Then we're gonna remesh, like I said, 20,000. Seems like a good amount. Do a smooth so we get some smooth edges. And I think this piece looks good as well. Change the pivot to be in the center. Check to see if there are any holes by pressing H fill. do a remesh to about 20,000, and then smooth everything out. You can delete some of the mesh pieces because we already have them saved as an actual static mesh in our folder, so you can bring them back if you change your mind. This process can be reused to do columns and statues and pretty much anything that you want to fracture. You can do this easily inside Unreal. I'm gonna continue this with the rest of our pieces and do this offline and just show you the end result. Here's what I did with our pieces. I just arranged them to create a hole in the middle that we can fill with some sort of ground. The first thing that I want to do is select all of our pieces and make sure that I enable Nanite back to them. Next, you can try out and see how this looks like. As you can see, our foot IK works perfectly with all of our pieces. They already have collisions enabled on them. Now we have a lot of elements inside our outliner, and a quick way is to select the meshes that you want to group together and then press the Create Folder button in the top right corner, and that would automatically create a new folder with your selection. I'm just gonna put the floor tiles and the fractured pieces inside an individual folder to be able to quickly expand or contract them so I can get to the other parts of our project. Another cool thing that you can do is, since we're using our blend material, you can also do mesh vertex painting on our fractured pieces. So you can add back our damaged detail or put in some moss. They act as if they are part of the whole scene. Next, I'm gonna look for some assets on Quixel Bridge. I'm looking for something with roots or some sort of a tree trunk, something that we can put underneath our broken piece tiles. And I'm going to use the high quality asset, which is the 4K asset. We don't need the Nanite one since it's 8K and it just takes a lot of space. I really like these ancient temple jungle roots from the roots category. I'm also adding some mossy pieces as well, so we can try and blend them with our moss material to see how that would look like. And I think this forest roots is a great example of both roots and moss, and also a base color that's similar to our own base color. You only need a couple of them, about 4 or 5 for now. We're going to add more at the end of the project when we're going to do our scene setup. For the tree, I'm going to use this broken stump. It's a bit small, but we are going to increase its size. Some of the Megascan objects have some issues with the default material, and we're gonna have to do a bit of a fix. If your objects appear white, all you have to do is open up one of them, go to the master material, usually it's the fuzz material that has issues, and change its shading mode from cloth to default lit. This will fix the white issue. I don't know why any material downloaded from Quixel looks like this, but it's an easy fix. I don't mind. As I mentioned, I'm going to increase the stump size to about 3. And I'm just gonna fast forward this and create a time lapse of how I'm going to place all these elements in the middle. I'm gonna add some moss and some roots. Once you're happy with how everything looks, you can test it out. If your Quixel meshes don't have collisions, all you have to do is open up the static mesh and change its collision to be complex collision treated as simple. Still have our lichen material, and for that one I'm going to import a decal from Bridge and change its maps with our baked maps. I'm going to select a moss patch, high quality, and add it to our project. You're going to get a new folder called Decals. And all you have to do is drag the material instance onto your scene. And it will automatically generate a decal. The decal will project the textures on top of our meshes, and it will blend with both our normal maps and our blended material. I'm going to duplicate the material instance and name it Lichen Patch. Change the maps to be the ones that we made in Mixer. We only need the albedo and the normal map. For the DRO mask, you can create your own opacity mask, or you can just leave the default one. I just left the default one. Combining the blend material with decals will give you an almost infinite number of variations that you can do with just one mesh. Before we can start using runtime virtual textures, we need to make sure that they are enabled. And in order to do that, go to your project settings and search for virtual textures. And make sure that enable virtual textures support is checked. You might need to restart the game engine. I already had them enabled for this. Next, we're going to create a folder to put in our virtual textures. Right click, and in the texture submenu you're going to see a new item called Runtime Virtual Textures. The first one that we're going to create will be the height one. You should double click to make sure that you change the type from color to just the height information. Next, you can duplicate the first one or create another one, and we're gonna name it VT material. And this one, make sure that it has the base color, normal, and roughness. Once you've done that, we need to add Runtime virtual texture volume to our scene, and we can search for it in the place actor section. We're going to need to change the scale of our volume to encompass all our floor tiles and assign the VT height to it. You can create another one or just duplicate the one that we just scaled, so you don't have to scale it again. And to this one, assign the VT material. Now that we have our volumes set up correctly, we need to assign to our floor tiles. You can select all 9 of them, scroll down to the virtual texture section, create 2 items, and select the VT height and VT material to the array elements. In order for this to work, we need to make some changes to our blend material master. Create a break material attributes node. And then we're going to create a runtime virtual texture output node. Plug in the color, specular, and roughness from our material attributes into the virtual texture attributes. For the normal, unfortunately, we need to convert it from tangent space to world space, since our material is working in tangent space and the virtual texture is in world space. We're just going to use the transform vector node. And for our world height, we're going to use the world position node and a component mask that only uses the B channel, which is also the Z height in the world position. And that's it with the surface or landscape part of our virtual textures. Next, we need to set up the objects that we want to blend. We need to first go and duplicate the master material so it doesn't get overwritten. We're just gonna rename or add RVT at the end of it so we know it's the RVT version. Same as with our blend material, we don't have access to the material attributes, so we're going to need to break them apart. We're going to start off with a runtime virtual texture sample parameter, and we're going to use a parameter because we can assign our virtual textures to them. The first one will be the VT material, which will be the material of our landscape or floor tiles. Select the node, and from the left sidebar, select the VT material texture from the dropdown and make sure that it's the correct format. Next, we're going to add a make material attribute node. And plug in the base color, specular, roughness, and normal from the VT texture into this node. You can select both of them and create a comment and just put landscape material or something that will make you remember what these nodes are about. Next, we're going to create the opacity mask that blends this object with our floor tiles. And once this is created, we're going to use the blend material node to put everything together. Create another virtual texture sample parameter and name it VT height. From the left panel, assign the virtual texture height to it and double check that it's in the correct format. Add a world position node and a component mask and select the B node. Create a subtract node and plug in the world height from our virtual texture and the component mask. Just like we did with our world position, we're going to create an object boundaries node and a component mask and select the B node. From our subtract node, drag and create an add node and plug in the results from our object bounds. We also need some sort of parameter to be able to change this quickly. So I'm just going to create a parameter and call it blend height, set the value to 1. Create a multiply node and plug in our parameter and our object bounds. Plug the result into the subtract node. Create another parameter and name it falloff. For the default value, I put 10 or 15. I found that to work best. And we're going to plug this one into a divide node. Next, we need to clamp this value, and the quickest way is to use a saturate node instead of a clamp from 0 to 1. Select all the nodes and you can create a comment for this as being object height or object material. Create a blend material attributes node and plug in our object height into the alpha and our landscape material into the A pin. We currently have our normal in tangent space and we need it into world space. Create a get material attribute node and add one array item. Select normal. Plug it in a set material attribute node and create one array item, again with the normal. We're going to use a transform vector node to change it from tangent to world space. Once everything is blended, we're going to turn it back from world space into tangent space by duplicating those 3 nodes and plug the output into the material attributes pin. Double check that you have default values for your parameters, apply everything and save it. I forgot to add the value to our falloff and I'm adding 15 as my default value. In the material instance, make sure you change the default master material to our RVT1. You can enable those new options so you can have quick access to them. And as you can see, our Quixel mesh and material blends nicely with our floor tiles. I realized I forgot to apply the virtual textures to our pieces. Select them in the outliner and add 2 array items, and select the VT height and VT materials for them. And now you can see that our mesh blends with the pieces as well. Now we can quickly change any imported object by just going into the material instance and changing the master material from the default one to the RVT one. Play around with the blend height. It's very important. If things don't work, try to increase the blend height or the fall off. I'm going to show you an example where we need to actually increase the blend height to the object because it looks like it doesn't work or it's broken. I'm gonna add a mossy static mesh and try to blend it with our floor tiles. With this one, even if you change the master material to the RVT one, at first it looks like it's not working. Trying to see if our boundaries have reset. This sometimes happens. You can click the set bounds or put in the values again. So it looks like it doesn't do anything, it doesn't blend, while the other one works just fine. As I mentioned, it turns out the issue was the blend radius. We need to set it to 1.1 or 1.2 rather than just the default value of 1. And this concludes our RVT portion of the tutorial. If you want to learn more, I'm going to leave a link in the description to a longer RVT tutorial with more in-depth explanations than mine. Ultra Dynamic Sky is one of the best paid assets that you can purchase on the Unreal Engine marketplace. And it's made by Everett Gunter. It has some amazing features out of the box, like a full day and night cycle. And in the latest version that's compatible with Unreal Engine 5, they've introduced a full weather system and volumetric clouds. First, we're going to have to install it or add it to our project and navigate to the blueprints folder. And then we have to first make sure that we remove everything from the lighting folder, even your skylight, your volumetric clouds, everything. And all we have to do is add back the Ultra Dynamic Sky blueprint and Ultra Dynamic Weather. You can put it in the lighting folder as well. That's it for the setup. You can control the weather from the dynamic weather blueprint. There's a drop down to control it, change it from clear sky to rain, sandstorm, and snowing. Let's see how the weather system works. We're going to try out the rain. As you can see, it currently uses the raindrops effect, but it doesn't create any sort of puddles, or the snow is not setting on our floor tiles. In order to fix that, we can take a look at how this was implemented in the demo materials. We're going to open the wall example and see that the snow and weather effects are just two nodes and some parameters. What we're going to do is select those nodes and copy them to our own floor tile material. Select the instance and open up the master material. Zoom out a little bit and create some space to paste those two nodes. Make sure that you copied all the parameter nodes. If we go back to the wall example, we can see that all we have to do is plug in the base color, roughness, and normal into those two nodes and the output into our material output. Unfortunately, we have a small issue. Since we're using the base color, roughness, and normal, we're going to need a make material attribute node first, and we can plug the output from there. Double check to see that everything is plugged in correctly. Click apply and save. And now we're going to see the weather system interacting with our floor tile material. The snow is setting on it. Hit play and check how this looks like. Test it out with the rain. It automatically applies a wetness surface to our floor tile material. And we can also enable puddles. They will appear inside our crevices. Make sure that you check puddles on the right as well. We can see water filling up those crevices that we have. Apply the same nodes to all the other master materials that we have, like the fuzz RVT material. Make a break material attributes node, since we need to plug in the base color and everything else. Plug in the base color, roughness, and normal. and the output to our material output. Click apply and save, and let's test this out with the rest of our elements. Now we can see that the mossy surface is wet as well. Our floor tile pieces, the ones that we created with the fracture system, are interacting with the puddles and wetness. We can also check to see if it works with the snow, and the snow is setting on top of every single mesh that we have. We can also check to see if our runtime virtual texturings are still working. Everything blends correctly with the weather system on top of everything else. Next, I'm gonna speed things up for the project Timelapse. I just downloaded a couple of more stone walls and some other elements from the Japanese collection. Remember that every time you add a new element downloaded from Quixel, you have to change the master material to our RVT one if you want to blend them with the floor tiles. I'm just adding some walls on each side, and since they are open-ended, there's no back mesh. We have some issues with the shadows that they cast, but a quick fix is to just add a plane, scale it out to the size of your mesh that you're trying to obstruct, and just put it facing outwards and the back face facing inwards, and that way the player will not see the actual plane, but it will create the correct shadows. I'm adding some more elements, scaling them up a bit so they fit better with the composition. Double checking to see if they have collision enabled. As I said, selecting use complex collision as simple. You can play around with different meshes or different elements from Quixel Bridge. We have the same issue here with the shadows. Like I said, you can just duplicate the plane, rotate it so the back face is facing inwards, so your player will not see the plane, but it will fix the shadows. You can rotate the sun by changing the time of day. For the foliage, I'm using a package called Forest Environment Set. I think it was free at some point on the marketplace, but you can use whatever foliage pack that you have. I'm just adding some grass with the foliage tool, putting it on top of our mossy corner pieces that we painted on the floor tiles. That way it will blend better with them. Placing some in the middle where the broken tiles and the roots are. Next, I'm adding some ferns or some medium plants. Do be careful with the foliage tool, as this is very resource intensive, and the more plants that you add, the worse your performance will get. I'm trying to put some ivies on the walls that we have. Next, we're gonna add a post-processing volume and make sure that you select the infinite extend or unbound option, so that way it will cover your whole scene. We're gonna add some bloom to start with. Give it that. Next, we're gonna set the f-stop in the camera to 1 so that we can get some bokeh or some depth of field. If we put the aperture to 1, we're gonna need some higher numbers for the lens distance, something around 300 to 500. I think 550 is the value that I'm gonna end up using it. And that way we can focus on our player, but we're gonna get some nice blurry backgrounds. In the ultra dynamic sky blueprint, you can enable volumetric fog, and you can increase the base fog density to give it a nice cinematic view. You can enable the sun shafts, lens flares, and pretty much every single option that it has. Change the depth of field to focal distance of 550, and that pretty much creates the blurry foreground and background that I was looking for. So basically any elements that are in front of the camera are gonna get blurred, and any other element that too far away from the camera will get blurred as well. If you've made it to this part, I congratulate you. This is my first tutorial. Thank you very much for watching this. Likes and subscribes are appreciated. This concludes our tutorial. See you in the next one.